Hello everyone. The purpose of this recording is to demonstrate the Backus-Naur form and part 3 for my laboratory exercise number 2. So I prepared this. My name is Ariston Javier. So let's start. Okay, first thing is I just need to give you some brief introduction for Backus-Naur form or BNF. So this one is invented by John Backus to describe the algo 58. And BNF is equivalent to context-free grammar or CFG. It's also used to describe the syntax of a programming language. And parse trees, okay. So parse tree is reveal the syntactic structure of the sequence of tokens that makes up a computer program to run. Okay. It's also very important that the grammar is not ambiguous or unambiguous. So it should all a program a grammar is always must be something like unambiguous to make it run. So why? If the grammar were if the grammar were ambiguous, program would not be portable because there would be more than one way that compilers could translate them. So it gives some confusion to compilers that may cause some errors and a wrong output for the given grammar. Okay, additionally, a parse tree always starts symbols at the root of the tree, and every leaf node is a terminal. So every interior node is a non-terminal, and the sentence appears in the left to right traversal of the leaves. So it also a hierarchical representation of derivation. So So we go through the okay. We grammar it can be ambiguity or ambiguity. So where is ambiguity is ambiguous or is when the grammar is ambiguous, which means it generates more than one distinct parse tree for the given expressions or input string. So unambiguity or unambiguous is when the grammar does not contain more than one left derivation or more than one right derivation or one parse tree for the given expression or input string. So unambiguity is most likely is the correct one for a grammar works in any programming language. Okay, so to make it fast, so we derive a BNF grammar. Let's try to derive a BNF grammar. So with a given BNF grammar. So this is a given BNF grammar that we need to derive. S something like a symbols is can be A non-terminal, and A non-terminal it can be A plus A non-terminal or ID non-terminal. So ID non-terminal it can be A terminal or B terminal or C terminal. So that's a BNF grammar that we need to derive. So we this is a given, then this is a given string that we need to derive. So you can see here we need to derive it to A plus B plus C based on this BNF grammar. So let's go through. So from based on this, we can derive it into the two ways as below. There's a two ways we can derive this here. So I show you the two ways. So it can be two ways or more, but I shall give you only the two ways. Okay. First is the leftmost derivations that I use. So if you can see here, the symbols I symbol it can be A non-terminal, and here you can see A is non-terminal because here in the top is A, and here I choose the A. I choose the A plus A because I need something like plus addition or plus operations based on the given string. So I choose this A plus A first. So A plus A non-terminal. Then the next level is I get the first A to get another A plus A non-terminal because I need a two addition operation. So here I change it, I convert it to A plus A. Then another one that have is A plus A. Then and here I already have a two operations for my string. Then I just shall need to convert it to the terminal. Okay. So this first A, I convert it to ID. Okay, this ID, and this ID I convert it to A because ID can be A plus B plus C, but in a given string we need to get the first A. So I convert it to A. Then the next letter A, the next A, okay, the next A, it can be also ID because I need to get the B. So the ID I get is it can be A or B or C, and the second terminal that I need to get is a B. So here the ID I choose is to I translate to B. Then the last one, the ID, last ID non-terminal I need to translate it to C because in the string I have A plus B plus C. So to get it, the ID I need to choose the C. So this is the string that I derive. So based on this derivation, I get the correct given string. So this is the first leftmost derivation that I do. So another one that I do, second leftmost derivation that I do is similar, but it may be a quite distinct derivation, but it give you a same output, which is this one symbols or something. Symbols it can be A, then A non-terminal, then A non-terminal it can be A plus A non-terminal. And here I will translate the next A, also right one, the right one of this one. So here I change it to A and I make it A plus A. So you can see here, from here you can see also is just similar A plus A, but this one I will do some right because I do some right, not the second lap. So I start in the second lap. So here you can see here, yeah, I first here I derive is translate to C because this is the last. Go to the B here and from A. So based on these derivations, or based on the first left mode derivation and second left mode derivation, I can say that this one is ambiguous because I can generate two same string with a different derivations. So as earlier say, ambiguous is when you can generate two derivation or two first three, and unambiguous is only one. So I mean to study more, so we go through we show you more on the how it derive it into the how it show into the first three. So next thing is derived expression using a first three. So here is the first three derivation. So from here you can see is the S is 3 A here A plus A and A is here. So this one we I don't need I didn't divide the ID. I just straight away convert it to A plus B plus C. And here is another one derivation. So from based on this presentation, there's a two distinct parts tree, but you have a one string output string. Okay, one based on the BNF grammar, you can generate a two parse tree, two distinct parse tree. Then this one is called something ambiguous. So that's why I think above is ambiguous. The parse tree are derived from some grammar's rules, but it generates two distinct parse tree. So there's a in this image there's a two distinct parse trees with the same grammar rules, which is A plus B plus C, and in the same BNet grammar. So we must note that ambiguity of grammar is considered as undecidable. So undecidable it means the compiler will be confused which way they will translate the grammar. So that's why the program it must be unambiguous to make it work. So they say there's no algorithm for removing the ambiguity of a grammar unless we rewrite it again. We just call this ambiguate the grammar. So based on this grammar expression, I try to make it unambiguous, but I will get same output A plus B plus C, but I may need to rewrite the BNN grammar as C below here. So what I do is disambiguate the grammar. So disambiguate grammar is where the grammar rewrite to make it only one derivation of parse tree possible for string. For example, the grammar may represent. So when you disambiguate the grammar, of course, you need to make it something like unambiguous, unambiguous. So make it something like there's only one derivation, only one policy to create based on the grammar rules and based on the string that you need to derive. Okay, based on the given PNF grammar and input string, we can rewrite the grammar to make it ambiguity or ambiguous grammar. So from you can say this is the from ambiguous grammar that I showed you earlier. Is a S. It can be A. It can be A non-terminal. It can be A plus A non-terminal or ID non-terminal, and ID non-terminal can be A or B or C terminal. So this is the existing one. So the current one that I want to make it frankly to make it unambiguous. So I will make it something like a one quite quick change. So instead S it can be still A non-terminal, but A terminal I make it can be A non-terminal A plus ID something like that. So it's something like a non-terminal plus constant or something like that, or ID or something called a it can be something like this. So this one it can be shortened as something like A non-terminal plus terminal or terminal, something like that. Or A expression plus something constant plus constant, something like that. So let's try to derive it to something to make it something like uh, how it can. Let's try to derive if we still can get the A plus B plus C. So this is a given string. So the leftmost derivations is something like this. Like say symbols or equal to A non-terminal and A non-terminal plus ID non-terminal. Then here is A. The first A I choose it. I change it to ID. Then the second one, the ID I convert to A. Then the second ID I convert to B. Then the third ID I convert to C. So so this one, if you use this BNF grammar that I use, is you cannot create another derivation. I cannot create any derivation that distinct that you can get the same output. Okay, so based on this BNF grammar that I changed, the disambiguate. This is something like a sort of ambiguous grammar. So here, this is ambiguous grammar. Okay, this the top one, the prompt is ambiguous, and this one is unambiguous. So I think that's all. Yeah, that's all for now that I want to